discussing about multiplication of a vector from grade 11. Before that, subscribe, share እንዲሁም ላይክ በማድረግ ቪዲዮችን ጀምሩ እንጠይቃለን። ከ11 ክፍል multiplication of vector a vector. Under this, we are discussing about three types of multiplication. The first one, when a vector multiplied by a scalar. The second one, the dot or the scalar product, and the third one, the vector product or the cross product. Now let's start from the first one, when a vector multiplied by a scalar. The first one, vector multiplied by a scalar. In this case, there are two cases. The first one, A, when a vector multiplied by a negative scalar, which means A less than 0, then the direction and the magnitude of a vector changed. Which means if we take 4 Newton force vector, if we multiplied by it a negative scalar by -3, then the direction, the original force vector to the right, but when you multiplied by a negative scalar -3, both the direction and the magnitude of the vector is changed. But when a vector multiplied by a positive scalar, only which is a greater than 0, only the magnitude of the vector changed. Which means, again from the above example, for Newton vector, if we multiplied by it a positive 3, then the direction is the same as the original vector, but the magnitude becomes 12 Newton. Hence, when a vector multiplied by a positive scalar, only the magnitude of the vector is changed, but when a vector multiplied by a negative scalar, both the direction and the magnitude of the vector is changed. Now let's see the second type of multiplication of a vector, which is a dot product or the scalar product. First, let's define the cross of the dot or the scalar product. The dot product of two vectors A and B is given by A dot B equals magnitude of A times magnitude of B times cos theta. This is the definition of the dot product. Now, the dot product of two vectors always scalar. That is why the dot product or the scalar product the dot product of two vectors always scalar. As an example, if we take a work done, work is the dot product of force and displacement. Both force and displacement vector, whereas work is a scalar quantity. And again, if we take power from the definition, work done over time, which is work again the product of force and displacement over, we have time, displacement over time, which is velocity, then power equals force dot velocity. Both force and velocity vectors, but power a scalar. Therefore, power is the dot product of force and velocity. If vector A is given in a component form, axi plus ayj plus azk, and again vector B, which is equal to bxi plus byj plus bzk, then a dot b equals under the bracket axi ayj plus azk dot with bxi plus byj plus bzk. Now, using a distributive property of multiplication, axi dot bxi bxi dot I plus by I dot j plus bz I dot k plus the first one and second one ay with bx, ay with by, ay with bz, which means ay bx I dot j dot I plus by j dot j plus ay bz j dot k plus again az with bx, az with by, az with bz, which is az bx k dot I plus az by k dot j plus az bz k dot k. But here note. Let's see the dot product of unit vectors. I dot I equals j dot j equals k dot k. This is equal to 1, because I is a unit vector which is magnitude 1. Again, I, a unit vector which is magnitude 1. From the definition, A dot B, magnitude of A times magnitude of B times cos theta. 1 times 1, 1 times 1 times cos. Since they are parallel, the angle between them becomes 0. Cos 0, which is equal to 1. Any number multiplied by 1, the number itself. Therefore, I dot I, j dot j, k dot k is equal to 1. But I dot j equals j dot k equals ki dot k, I dot k, which is equal to 0, because I is a unit vector along the x-axis, j is a unit vector along the y-axis. They are perpendicular with each other. The angle between them 90 degree, or the integral multiple of 90. Then cos 90, 0. Any number multiplied by 0, which is equal to 0. Now from this, I dot I, which is equal to 1, j dot j, which is equal to 1, k dot k again, which is equal to 1. I dot I, j dot j, k dot k. But I dot j, 0 times any number 0. I dot k perpendicular, again this product becomes 0. J dot I, this product becomes 0. J dot k, since they are perpendicular, product 0, 0, and this becomes 0. Hence, A dot B equals ax bx times 1, ax bx plus 0, 0, 0. But here, j dot j, which is equal to 1, 1 times ax by. No, this is ay, by plus, this becomes 0, this becomes 0. Then az bz times 1, az bz. This is the dot product of two vectors if it is given in a component form.